So now let's take all of the work that we've been doing on computing slopes and slopes of lines and working with the slope-intercept form to answer some questions posed by a word problem. So here's the first example where we're looking at a city's population in the year 1963, which was 2,540,950. But in the year 1998, the population had decreased, hadn't it, to 2,532,200. And it says compute the slope of the population growth or decline and then interpret its meaning. So we are going to make two order pairs, one from each of the sentences that we see in the problem. And if I ask you which variable you think is acting as our input variable and which variable is acting as our output variable, what would you say? Okay, so what value is dependent on the other value? Well, if you think that the population of the city is dependent on the year, you're absolutely right. So that means that we're going to let X be the year. And that's our input variable. And then we're going to let Y be the population of the city, or the city's population that year, in year X. Okay? And so that's our output variable, which means that we can set up these two order pairs, okay, with year. So let's set up the two order pairs with the year as the X coordinate and then the population as the Y coordinate. Okay, so there they are. There's one order pair, and then here's our second order pair. And then we've been asked to find the slope. So we are going to use our slope formula. So let's just label these x1, y1, x2, y2. And so slope will be difference of the y's. Well, let's remind ourselves. y2 minus y1 over x2 minus x1. So difference of the y's. So we put in here our y2 minus y1 over the difference of the x's. So we're going to take our x2 minus x1, which is the difference of the years, and that would be our run in our graph, right? Okay, and then we just need to subtract these two populations. And that gives us a negative 8,750 over and then 25. And now when we divide, we get a negative 350. So let's interpret that slope. What information are we getting from that slope? Well, what's happening to the population as the years are going by? Yes, it is declining, isn't it? The population numbers are going down. By how many people each year? By how many people? Yes, it is by 350 people each year. So that's the slope. The slope tells us that the city's population is declining at a rate of 350 people per year. So I wrote that down. So let's read it again. The city's population is declining at a rate of 350 people per year. And notice that the fact that I used the word declining in the conclusion statement means that I didn't put a negative 350. Do you see that? In my conclusion statement. So the slope is negative. That's telling us that it's declining. So this next word problem says Jake is a door-to-door vacuum salesman, and his weekly salary S is given by the linear equation S equals 320 plus 120V, where V is the number of vacuums sold. Identify the slope and explain its meaning. So first of all, the input variable is, let's write these variables down. It's V, which is the number of vacuums that Jake sold, right? So that's your input variable. That's acting as your X. So the number of vacuums sold. And then S is our output variable, and that's Jake's weekly salary, isn't it? So as you look at that equation, if we rewrite it, S equals 120 times V plus 320, what would the slope be? And if you said it was this coefficient of V, you're absolutely right. So what is the meaning of this slope? What information is that giving us? Well, now remember, here's the clue. Let's rewrite that slope as a fraction. Remember that slope is the difference of y, so it's output, difference of output over difference of input. And our output here in this particular word problem is dollars, isn't it? It's salary. It's money, right? because we're keeping track of Jake's salary each week. And then our input is number of vacuums that he sold. So when we have 120 over 1, then this 120 is difference of output, so that's $1. And this input has to do with vacuums sold. So 120 over 1. So that means that Jake earns $120 for each vacuum that he sells. Did you see how we got that? Let's write that down. So Jake earns $120 per vacuum sold. Okay, that's the interpretation of this slope. Now it says find the vertical intercept and explain its meaning. So that would be like our y-intercept. And going back to the original equation, that would be this 320. This 320. So that means what? What does that mean? That means that 0, 320 is the vertical intercept or the y-intercept as an ordered pair. And then remember that the input was number of vacuums sold, and that the 320 is Jake's weekly salary, right? That's our output. So what information are you getting from this 0, 320? Well, that would be Jake's base pay, isn't it? So even if he doesn't sell any vacuum cleaners that week, so 0 vacuums sold, he will still earn $320. So let's write that down. So the meaning of the intercept is that Jake's base salary, that means before he sells any vacuum cleaners, is $320. And I put per week, or you could have put it, we could have written Jake's weekly base salary is $320. For part C, it says find Jake's salary when 46 vacuums are sold. Explain its meaning. So here's our equation. I rewrote it there. And that means V is 46. So of course we're going to substitute in for V. And then we will do this arithmetic here. And we get 5,840, and this is dollars, isn't it? So what's the meaning? Yes, that is it. When 46 vacuums are sold, Jake's weekly salary is $5,840. So I'm going to write that down. When 46 vacuums are sold, Jake's weekly salary is $5,840. Then in part D, it says find the value of V when S equals 6,560. And this is a cool calculation, right? Because let's say that Jake's has a bill coming up and he wants to make sure that he can cover that bill. And he knows he wants to earn at least 6,560. Let's say exactly 6,560. And so how many vacuums does he need to sell to do that, right? So this is a calculation that is a very useful real-life calculation. So of course we're going to substitute the 6,560 in for S in our equation, and then we're going to solve for V. That's going to tell us then how many vacuums he's going to need to sell in order to meet his goal, his salary goal. And that's something that we can all relate to, right? Okay, so I'm doing this math here and dividing and getting V equals 52. So Jake has to sell 52 vacuums in order to earn $6,560 that week. And I will write that down. So here it is. In order to earn $6,560, Jake must sell 52 vacuums. Well done.